Welcome to math lessons 16 and 17, ratio and proportion. A ratio is the relationship between two numbers. It could be written as 4 to 2 with the word 2 in between. It could be written as 4:2, but we can't do anything with them when we write them that way. They are as awkward as Roman numerals. So we want to put the ratio in a form that we can use with a proportion. So we put one over the other, but although it looks like a fraction, it's definitely not a fraction. So here's 4/2 equals what? Now, if that were a fraction, we could reduce it down to the whole number 2. We can't do that because it's a ratio and we have to maintain the top number and the bottom number because it's not a fraction. So we start with 2 when we reduce a ratio also. 2 into 2 goes once, 2 into 4 goes twice, and that's it. That's the ratio when we reduce it as far as we can. We keep the bottom number. We keep the 1. Here, 3 will go into 3 one time, 3 will go into 9 3 times, and there we stop because it's not a fraction, it's a ratio. So we can only reduce them when we keep the bottom number. Now, when two ratios are written together, that's a proportion. They're equal on both sides. And the way to work a ratio is to cross multiply the one that has the number that has another number across from it in the shape of an X. There's nothing here, but this is two numbers. 4 times 4 is 16. Then, to get the X, the missing number, you divide by the one that has nothing across from it. So 2 into 16 would be 8. And that's what X is. X equals 8. So if you were to reduce this, you could get 2/4. You could get 1/2 because it's the same proportion. When you work a proportion with a calculator, it's really easy because you don't have to do it as 2 separate steps. You just say 4 times 4, divide by 2 equals, and it'll give you 8. So just like that, not writing the multiplication separately from the division. It's all one smooth operation. And here we have 3 times 18, 24, carry 2, 3 and 2 are 5, 54, to be divided by the one that has nothing across from it, which is 9. So you know that 6 times 9 is 54, so that's an easy one too. The X is what equals 6. So if you were to reduce, say 3 into 6 goes 3 times, 3 into 18 goes 9, does not go 9 times. Let's see what I'm doing wrong here. The X equals 6, so this would be 2 into 6, not 3. I should have started with 2 like I always do. 2 into 6 would be 3. 2 into 18 would be 9. Okay? That's the proper way to reduce it, and they're equal. This side is always equal to that side in a proportion. All right. And that concludes. By the way, there are some lessons that seem very easy. For example, rounding off is usually easy, but some students take a very long time to get it. It's the way your brain works, I think. And this may look very simple, except that I've had students who request a review of it repeatedly, and they're very smart students. I had one student who every Saturday morning in the Saturday class would request to review ratio. It didn't seem to make any sense to him. And each of us is different in what's easy for us and what's not so easy for us. But it's similar to having a learning disability. If you have a learning disability, that doesn't mean you're dumb. That means you're smart in every area except that one subject. And in that subject, your mind, your brain doesn't process things the way it does in the other subjects. That's a specific learning disability. Many people have their specific learning disability in math. And we are required to make accommodations. So if you can provide a test that shows you have a learning disability, if you were in special ed and you can get records from your school, you can probably get accommodations because the law says we must accommodate. And on some tests, the accommodation amounts to twice as much time. Now on a long math test, that's a lifesaver for someone who has a learning disability in math. So that concludes our work with the ratios and proportions.